For part 1 of this question, we are supposed to recognize the pattern so that we can quote the length of the nth piece of string that is cut off. What I'm going to do is I'm going to build a table, to try to recognize the pattern, and that is according to what we have discussed in our outline. It is a little bit overkill for a question that is like this, because I think many of you will probably be able to quote the pattern, just by looking at the way the question has described it, but I'm just going to be using a table. A bit of overkill, but I think it's still going to be a good practice, so for the table, I've decided it to be in terms of here, I'm going to look at the piece of wire that we, piece of string that we are looking at, and for the other side, I'm going to look at the length of the string that is being cut off. So according to the question, for the first piece of string that is being cut off, it is going to be 128 cm, and for the second piece, it is going to be 2/3 of the first piece length, so it is 128 multiplied by 2/3. And it is the same for the successive pieces that are going to be cut off. So for the third piece that is going to be cut off, it is this 2/3 and multiply by another 2/3. So this is 128 multiplied by 2/3 to the power of 2. And the pattern that we see here is actually really pretty obvious to me. But if we were to make use of how we have analyzed pattern in our outline, we need to recognize sort of like a 2D pattern over here. It is not just a pattern that I see here, it is because the pattern that I see within a row, it is always 128 multiplied by 2/3 to the power of something. And that is the first, the first dimension of pattern that we recognize. The second dimension, it is from row to row, where I also need to recognize that pattern. So 1, it is 2/3 to the power of 0. 2, it is 2/3 to the power of 1, and 3, it is 2/3 to the power of 2. It is always 1 less than this. So if I were to take this pattern and use it for the nth piece of wire that is being cut off, it is 128 2/3 to the power of n minus 1. Basically it is just a GP that we see here. Like what I was saying, this process is very much of an overkill, because you can probably code this directly by recognizing that the 2/3 that is given, it is going to be the common ratio, and the first term is 128. But anyway, what the question one is for us to find, to show that the ln of P, this is P, the length of the nth piece of wire. So this is going to be equal to P. I'm going to just ln this, and attempt to show what the question asks us to do. So P, which is equal to 128 2/3 to the power of n minus 1, ln P will be, of course, ln of this. 128. 128 is actually 2 to the power of 7. So I'm going to rewrite this as 2 to the power of 7. 2/3 to the power of n minus 1. So ln P is going to be equal to, applying the law of logarithmic function, this is ln of 2 to the power of 7, then plus ln 2 to the power of n minus 1 minus ln 3 to the power of n minus 1. So what I have here is 7 ln 2 plus n minus 1 ln 2 minus n minus 1 of ln 3. And the question requires us to re-express this, so that it is reorganized into terms of ln 2 and terms of ln 3. So this, if I were to combine, it is 7 plus n minus 1 of ln 2. This I'm going to change it to plus, because that is the requirement from the question. So I'm going to bring the negative in. So it's minus n plus 1 of ln 3. So this is going to be 6 plus n, or n plus 6, because the question wants us to have the n term as the front. So this is n plus 6 of ln 2 plus minus n plus 1 of ln 3. This will help us to compare and identify what are the constants a, b, c, and d. Since the question says that this is supposed to be the same as a n plus b of ln 2 plus cn plus d of ln 3. That is why I can see that a is going to be equal to 1, B is going to be equal to 6. C is going to be minus 1 and D is 1.